Eli Leland, co-founder and CTO of Voltaiq, which developing and manufacturing high-quality battery-powered products with a deep understanding of battery behavior, that sort of thing. That's that PR talk there that Scott gave me. But essentially, what does that boil down to? Put that in layman's terms.
Sure. So Voltaiq is an enterprise battery intelligence software company. So we are actually pure software, and we are an analytics platform for the entire battery ecosystem and battery lifecycle. And so it sort of starts with this fundamental understanding that batteries are poised to become this next great platform technology that's going to sort of, change and impact so many different applications, transportation, obviously, communications with mobile devices, the way we power our homes and buildings and the grid. Batteries are going to become this, are becoming this foundational technology underneath all of that. And they're going to have the scale and impact similar to, say, semiconductors and microchips or the internet or the internal combustion engine. That's the scale of transformation that we're talking about. However, batteries are fundamentally unlike the mechanical and semiconductor devices that most of our familiar technologies are built on. They're fundamentally much more complicated. They have lots of complex chemistry and physics going on inside them all the time. They're very sensitive. Their long-term performance, degradation, and failure is dependent on everything from the materials that go into them, the quality of the manufacturing process, the way they're handled before usage, and then the way they're used throughout their lifetime. And from our perspective, that makes them much more like organisms than like simple, mechanical or semiconductor devices. And as such, in order for batteries to truly achieve this potential that we see them taking on across all different sectors of our industrial economy, you really need to monitor them and measure them and analyze them empirically throughout their entire lifetime under every possible application scenario as you're doing R&D and product development. And so what Voltaiq is, it's a software analytics platform that automatically aggregates data from batteries from across the entire life cycle, both performance data, sort of the heartbeat of batteries' current and voltage curves as it's charging and discharging as it's over its lifetime, as well as all of the descriptive data, the metadata that describes what made those batteries, the manufacturing conditions, the ingredients that went into them, the operating parameters, et cetera. And then we use that information to help customers get to market faster with their products, improve their supply chain quality, reduce product liabilities and risk, and optimize the financing on them on things like warranties, lease pricing, that sort of thing.
So do you get into helping battery manufacturers just basically make a better battery through chemistry, or is it more through finances?
We do. We operate all across the life cycle. So it is primarily a technical software product. There are financial stakeholders whose priorities are going to depend a lot on the quality and health of batteries, but we do a lot of work up front in R&D and product engineering, kind of across multiple different sectors in the battery field, both with the companies that are making the batteries themselves or even their suppliers. We work with the mining companies that produce the lithium like Albemarle or the graphite like Pyrotech that go into these batteries. We work with the battery companies themselves. We work a lot in consumer electronics and the transportation sector, basically helping to streamline and accelerate all of the analysis, the data collection and analysis that is vital to developing quality and high-performing battery products, and then optimize the performance of those products at those early stages.
One of the issues that has occurred frequently in the last few years is just airplanes, cars, consumer devices catching on fire because of the batteries catching on fire. Indeed. So how do you prevent that?
That's a great question. So so there are a couple different answers depending on the type of system that you're looking at, right? So it's a little bit of a different challenge when you're talking about a consumer electronics device powered by a single battery cell versus a vehicle system where you've got hundreds or even thousands of battery cells involved. But there are a number of different things that a company can do to mitigate this fire risk. Part of it is, fundamentally it requires thinking about batteries and battery quality and battery safety across the entire life cycle of your device and system. So all the way upstream, these OEM companies in consumer electronics or transportation, they're getting battery cells from suppliers typically overseas. And so one thing that they can do is really lean on their suppliers to ensure that the best practice quality practices are being followed at the manufacturing stage. Very fundamental things, we hear about battery fires and recalls today being caused by things like folds in the separator layer or tears in the electrode. These are typically, a lot of these problems can be caught during the manufacturing stage using things like X-ray or just even image recognition as these things are coming across the line. And then the OEMs, when they get the cells from their suppliers, can require, we encourage them to require that they get a full sort of data packet that describes each and every cell that they're getting that's going to be put into their vehicle. So this is technologically possible. There are some cell suppliers that do this and some OEMs that require this, and there are others that don't. So we definitely think that that's fundamental to ensuring quality products. Then when you're looking at actually designing the product, so there's a couple different things. You need to do a full qualification and validation cycle on these batteries as they're going into your product. So that involves extensive testing under every possible application scenario. Basically, you can do this whole kind of regimen of you test batteries at different temperatures, at different rates of charge and discharge, and you can kind of come up with a full characterization of that battery's performance over its entire lifetime. You have to cycle many of these batteries until they fail, until they, either catastrophically fail or drop below some, required performance threshold. So we help streamline all the data collection and analysis and tighten the iteration cycles, the development cycles that are going into developing new battery products and developing new battery powered products. And then the technology exists to monitor these batteries throughout their entire lifetime, especially when you're looking at vehicles. I guess one step before that, when you're engineering vehicle battery packs, again, there are best practices that we see in the industry around things you can do to design a pack with the fundamental understanding that every so often there will be a defective cell, and those cells could potentially, self-combust. We've seen it happen over and over. We encourage an approach that you design a pack that's robust to those types of failures that don't lead to a catastrophic cascading failure where the whole battery pack burns up, where you can provide some physical isolation between the battery cells. You can make it so that the cells themselves can disconnect from the rest of the battery pack if the cells are beginning to fail. And then you can also monitor these packs over their entire lifetime and do proactive service interventions when you see early signs of failure, both on individual packs and then recognizing patterns across entire fleets. So these are best practices that are employed by some of the leaders in the industry, and that we see a lot of the industry needing to catch up on.
Does this use AI? Is that how you kind of monitor all this stuff, or what?
That's definitely an important component to it. So fundamentally, a lot of it is an issue of just providing the plumbing and the kind of data infrastructure to collect all of this. When we started the company, back in 2012, one of our fundamental insights, it was that sort of batteries are complicated. They're a data-driven challenge. You can't just model them or qualify one commodity source of supply. You need to constantly test them. So there was that. The second one was that these battery systems were already generating this data throughout their entire life cycle. This is true when we started the company. If it's in an R&D lab, it's coming out of test equipment. If it's in a vehicle, there's the battery management system that's producing a detailed log of that battery performance. And typically, there's telematics in place to get this data back up to some centralized location where you can do this. So a lot of the work we do is helping customers take all this data that they're already generating that they could derive tremendous value from in terms of improving product performance, quality, safety, et cetera, and getting it in automatically into our platform into a single common format where you can then apply our best practice battery specific analytics to derive this value. When you look across large fleets of batteries and identifying patterns of failure that might be subtle, that might be more difficult to detect than a single operator just looking at a computer screen can detect, that's definitely where the machine learning and artificial intelligence angle comes in.
So is the background of the people in the company in chemistry or in data science or a little bit of both?
All of the above. Excellent question. That's, that's kind of the part of the special DNA of Voltaiq. So myself and my co-founder both come at it from, I sort of have a hybrid background. I worked in enterprise software early in my career. I then went to get a PhD in mechanical engineering with a focus on energy generally, wanting to work on energy technologies. My co-founder also has a PhD in materials science. Coincidentally, I know your last segment was with Pajarito Powder. My co-founder actually started a fuel cell company coming out of grad school, and that sort of ran its course. And then we actually met together working in a lab where he was leading a project to develop and commercialize a grid scale battery technology. And I was working on some other electrification technologies as well. So we've got this deep energy and battery science background. We've filled out the team with multiple PhDs in chemical engineering with focuses on batteries, battery engineers, who used to work at places like Apple and other leading startups. But then we also have a very robust software engineering team with extensive experience building large scale data systems. And then the sort of third component of it is excellent product design. So taking sort of best practice principles for making intuitive, easy to use products and combining those three pillars of expertise.
So are you working with any Detroit auto OEMs?
We are, can't say who, but yes, we are. A couple other customers in the transportation sector I can mention are Mercedes-Benz R&D North America has been a customer for some years, Proterra, which is the largest domestic maker of public transportation. And now they're also getting into supplying battery packs to heavy equipment. They've been a customer for a number of years as well. And then we work with some of the flying taxi companies, Uber Elevate, which was sold to Joby Aviation is another example. So that's just a cross section of who we work with in the transportation sector.
And do you see, because the earlier guest was talking about hydrogen, that it would be used in long haul vehicles, that sort of thing first, and maybe come to passenger vehicles second? Is that the same scenario that you see with your technology or different?
So, we have a somewhat biased view, like we're all in on batteries. Our mission is to help accelerate the transition to a battery powered future, which is, where we see things going. We see for most certainly like consumer terrestrial transportation and a lot of heavy equipment and delivery vans and all that stuff. For the bulk of what we see today is we think it'll be battery powered. We do see that there will be certainly applications where hydrogen and fuel cells make a lot of sense in terms of I think long haul trucking, shipping, aviation, those are certainly places where we see fuel cells having a lot of potential. So, we don't see them as necessarily competing technologies, more complementary. I know it's been said that, a rule of thumb you can think about is where you see diesel in application today, that's a likely good application for fuel cells, and everything else basically where you're looking at gasoline combustion engines, that we see those being replaced by batteries by and large.
All right, well, we've come to the last minute of the segment. So if people want more information on Voltaiq and what it is that you offer, how do they get a hold of you?
We would welcome anyone to visit our website at Voltaiq.com. That's Voltaiq.com. We also have a publication, a Medium publication, where we write a lot of articles on, sort of what we see as trends in the battery industry. That's called Batteries Are Complicated. If you just Google Batteries Are Complicated, you'll come right to our Medium publication, and you'll see a lot of content that we've written up on a lot of things we've talked about today.